Okay, so we're talking about inequalities today. But since we're moving slower, relatively speaking, I want to go back and review the stuff that you need to know for this next test that we learned last week, like right before break. So here's one of them. These are a lot nicer if they don't have fractions in them. What makes it a fraction? The fact that it has a denominator. How do I get rid of the denominator? Multiply by that denominator. So go ahead, multiply each term of this by x plus 4. All right, now. On your paper. I can cheat and make an infinite cloner here. There, I multiplied everything by x plus 4. Now I actually multiply it out. This is the grinded out details kind of test. Newsflash. Generally speaking, teenagers are not good at details. They make too many little mistakes. I do too. I can relate to you. But this test is a lot of little details. So if you don't test one of your intervals right, a lot of times your test questions will have like 5 things you need to test. If you test one interval wrong, you're going to think it goes up when it really goes down, and you get the whole thing wrong. So it's about grinding out the details. All right, you should know that those cancel and just get x. And 4 times x plus 4 is 4x plus 16. A lot of people forget to multiply the 4 by both parts. 9x plus 36. And do I even have an x squared anywhere in this thing? No, so this is going to be a fairly easy one. Okay, because there's no, it's not even a quadratic. So then I would get it down to 5x plus 16 equals 9x plus 36. Then I got x's on both sides. Get rid of the smaller one. 16, 4x plus 36. Subtract 36 from both sides. Negative 20, 4x. Divide by 4, negative 5. Raise your hand if you had negative 5 for your answer. All right, good. You cleared a fraction. That's what that's all about. And there's going to be harder ones like that on the test. What if it looked like this? I can't multiply by x plus 2 because it won't fix the whole thing. I can't multiply by x plus 3 because that won't fix the whole thing either. So I have to multiply by x plus 2 times x plus 3. And I have to do that infinite cloner there and over there. And that's a much more difficult one to solve. But bottom line is it's the same process. You just got to know you multiply by both of them together. So this would cancel this. This would cancel that. Nothing to cancel over there. So it's going to be just a lot of grinded out kind of stuff. Do you understand how to do this kind of problem? Give me like a little nod or something if you think you get what's going on here. All right, if you don't, then you should see me and I'll show you how during work time today. All right. Here's another review, and it reminds me to remind you that you need to know that big formula. If you know the formula, write it on your paper right now. It starts with amount 1. Know the mixture formula I'm talking about? It's got an amount. It's got a percent. If you don't remember that formula, you need to learn it again. This is not like review for the final. This is just review for the test that's coming up, the next major test. And it's the last one, and it's the hardest one of the quarter. Not to say you can't get an A on it. Absolutely you could, but you're going to have to be detail-oriented, careful. Remember a couple formulas. All right. So, amount 1, percent 1, plus amount 2, percent 2, equals amount 1 plus amount 2 times total percent. Raise your hand if you had that formula. You knew it. Good. Okay. Now, 90% acid. It doesn't say how much. What do I put for that then? X or N or something like that. times 90% plus 5 milliliters of 80%. It brings it up to 82%. Well, that's this total. But what's the amount 1 plus the amount 2? You go back to what you said they were. Amount 1 is n, amount 2 is 5, so it's n plus 5. See how there's only an n? It's the only variable in this whole equation. So you just multiply it all out and you solve it. Try it right now. This is basic algebra. So often, in Precalc and in Calc, this comes down to basic algebra. So you can't practice this too much. It reminds me of that old saying that you can't add too much water to a nuclear reactor. It's just a funny saying because you can't tell if they meant you really don't want to add too much water to a nuclear reactor, or you can't add too much water as in like you can have lots of water at a nuclear reactor. So you can't add too much water to a nuclear reactor. All right, 0.9n. 8 times 5 is 40. I can do that in my head, but then I got to move the decimal back a spot, 2 spots in fact. So 5 times 0.8, let me make sure this makes sense. 580 cents is going to be $4. All right, and then 0.82n plus 5 times 0.82. 5 times 8 is 4, and then 5 times 2 is 4.1, I think. Somebody with the calculator wants to overrule me, I'll gladly take the help. And then 82 cents. And then 90 minus 82 is going to be 0.08, and subtract, that's supposed to be a plus, subtract 4 from both sides. So final answer, did you get 0.1 over 0.8? Is it 0.08? Ah, you're right, I dropped the 0 right there. Being careful is just what we're talking about. It's so hard to not make those little dumb mistakes. Okay, so 0.1 divided by 0.08, I have no idea what that is. 5/4? Seriously? It could be. Can anybody verify that? Oh, good. So if it's 5/4, then that's another way to say 1 1/4. Now, or 1.25. If I look back in my original problem, I want to make sure that makes sense. All right, I had 90% acid. I don't know how much of it, but there was 5 milliliters of 80% acid. That's a pretty small amount of acid. 5 milliliters is like 5 little tiny cubes. Milliliters are a centimeter on each side. So it's 5 little cubes of acid till it brings it up to 82% acid. So it's only going to go up a little bit. It only goes up from 80 to 82, so I'd only need a small amount of acid to make that happen. So the answer is 1.25. That makes sense, that it would be a small amount. There we go. And 1.25 milliliters would be smart, since I was looking back at the problem. Always do that at the end. Make sure that your answer makes sense to you. So at least you're not off by like a decimal place or something dumb like that, like 12.5 instead of 1.25. All right. This is the kind that you did yesterday. First thing you'd have to do is factor it. Do you remember this perfect square? What does it factor to? X plus and x minus what? 2. So then I got 2 spots. Where do I put them? On the sign chart. Here's -2, here's +2. I'd like you to fill in the rest of the sign charts with this kind of stuff, and whether these are open or filled in, I totally did that wrong just on purpose, but all right, so just you fill out the rest of that sign chart for it now. Remember, the pluses and minuses go above the line after you checked intervals. Stay motivated here. We're not going to be at this too much longer, and you'll be set free. All right, in back corner pocket, tell me something you tested.
0.
Okay, zero's in here. Did zero, well, it's not whether it worked or not. It's did it come out positive or negative when you put in 0? Okay, here's how I'd show it. I'd have 0 plus 2 is positive here, and this one right here came out negative. Positive is a negative, makes negative. Raise your hand if you had that same. Okay, good. Then give me another one that you tested. Mr. W. Okay, -3 would be over here. Did you find it came out positive or negative? All right, it would be negative here, and it'd be negative here. This one's negative, and that one's negative, so that makes it positive. You are correct. Okay, Miss F in the front row. +3. What'd you come up with? Positive, that's not working. It comes out what? It comes out positive. That's what I'm trying to get at. We don't judge whether it worked or not until later. Right now we just say it came out positive. Now, it is true that in this case the problem says greater than 0, but they're not always going to say that. So I don't want you to think of positive as working. In this case, yes, we're looking for things that are bigger than 0. So yes, it works here and it works here. And how do I write the final answer? From -infinity up until, oh, wait a minute, I don't even know if it works there or not. So let's test -2. Does -2 actually work? Well, -2 would make this part 0. Is it okay if this whole thing is 0? Yeah, 0 is greater than or equal to 0. So it works here and it works there. So now, final answer. I'm looking for things that are bigger than 0. That's here including that spot and here including that spot. So you'd say -infinity to -2 with bracket here, parenthesis here, union with 2, bracket there because it worked at 2, and infinity. There we go. Raise your hand if you're comfy with that kind. Feels solid. All right, good. And let's move on to the next. These are kind of weird because they don't have sign charts and they don't have pictures. You have to think them through. When is x squared less than 0? Ever? Never? So how do I write never? Yep, this works. All right, how about this is always what? Positive. How about this? It's always negative unless it's what? So basically this is always a positive times a negative. What's that make? A negative. When is that less than or equal to 0? Always. How do you write always? Because even 0 works. 0 is equal to 0. How do I write always? Or you could say that. All right. This one. What jumps out at me is I see 3 things. 1, -3, and 7 right off the bat. Are those important things? Yep. You just put them on the line. Don't have to do this one. Just reminding you, big picture, this is how you start all these problems. Then you test each of these spots. They'd all make it 0. Is 0 actually less than 0? No, it's not. Empty, empty, empty. It's really important to not think that those spots always work. They don't. And then you test the intervals around it. Okay. This kind. On this kind, you're going to need to do both the x-intercepts, which is what these were. These are the x-intercepts. It's where the whole thing would equal 0. Okay? You need the x-intercepts still, but on this, the x-intercepts are found on the top. Because it's x-intercepts where y is 0, and whatever's on the top makes 0. The verticals come from the bottom. That's this and this. And so, all 3 of those things go on your number line then. Okay, so I got a 2. I got another 2. Wait a minute. Oh, that's a sign that it reminds me of something. What's that? These 2 being the same. Tell me again. They make a whole. You are correct. So they're really not asymptotes, are they? Is it still an x-intercept? Yes, but it's an x-intercept where there's a what right there? There's a hole right there. So 2 is still an important spot, but there's a hole there. You put an empty spot there. That means the function's not defined at either a hole or an asymptote. Okay, next thing. The verticals, asymptotes. You put them on your little number line. There's an asymptote here at -4, so I go over to -4, which would be like over here, and I put an empty spot there because asymptotes never work. If you want to just put it in there and find out, go ahead, but you'll find out that there's a 0 on the bottom, and as soon as there's a 0 on the bottom, the whole thing doesn't work. All right, so neither of these two endpoints work. Then we check to see if these are like pluses or minuses or whatever they are, and then we finish the problem that way. All right, I want you to do one just like that. Try this. Oh, and I need to know if it's greater than or equal to or less than or equal to. Less than or equal to 0. So the question really is, when is this function less than or equal to 0? And you got to make a sign chart for it. You do not want to try to graph these. Some of them have really funky asymptotes and things that make it complicated to graph. And since you don't have a graphing calculator on the test, sign chart definitely the way to go. Okay, Mr. D, tell me a number that's on my number line. 4 is, because that makes an asymptote. And since it's an asymptote, does it work or not? Asymptotes do not work. You probably make up a funny saying about that. Next, -5. You get how that's an important spot? Is that a spot where this is positive or negative, or no, it's a spot where it's an asymptote, so it's an empty spot. It does not work there. And the last one is -7 from the top. That's an x-intercept up there. And does that work? Again, if you're not sure, just stick it in, find out. -7. If I stick it in here, oh, the top turns into 0. Is 0 less than or equal to 0? Yes, it is, so it works there. And then you'd test all the regions around it. Do it quick. Shouldn't take you very long. It's basically our last one. See if it's like plus, minus, or what it is. I'm telling you, from grading a lot of tests on this topic, I remember a lot of people test intervals wrong. All it takes is to test one little interval wrong, and you thought it was positive, but it was really negative. Lose all your points. All right, so it's got one of these dealy bobs, and if I test something like -8, see if it works or not. I'm going to cheat and use this as an infinite cloner so I can like show my work in each of these little intervals. I'll go, if I stick in a -8, it would be like this. And I'd have a negative on the top, and a negative in the bottom left, and a negative in the bottom right. I was amazed how many people didn't know what that meant. That's a negative over two negatives. Is the final answer going to be negative or positive? Negative. Because every two negatives cancel each other off. And well, this one, the two will cancel each other off, but there's still one left. Final answer is negative. All right. If I stick in something that's between -7 and -5, that would be -6. So if I stick in -6 right here, the top becomes positive. -6 right here, the bottom left is negative. -6 right here, negative. A positive over two negatives makes the two negatives cancel, turns into a positive. Positive. Negative, positive. How about this one? Do you think they are? Negative, negative? Positive, positive? How about this one right here? Raise your hand if you think it's negative. Okay, how about this one on the way right? What do you think it is? Positive? Raise your hand if you think it's positive. All right, that's most of you. All right, so let's assume that those are right for a moment. I should probably check them once. If I can check 0 quick, it would be positive, positive, negative. That makes negative. Good. Check that one. This one, if I stick in 5, it would be positive on top, positive, positive. That'd be positive. Yay. Okay, final answer. When is it less than or equal to 0? Well, we know it's less than in this zone, and it works right there. And then it's less than in this zone, but it doesn't work on either end. So we're talking negative infinity to negative 7, where it works at negative 7, union with negative 5 to positive 4, sorry. And it works right, or no, it doesn't work right there. And that's it. Whew. Tedious, but not very hard. I hope that's what you feel after this. Raise your hand if you could have done that problem right from start to finish. All right, good. Then we are done for today. Your homework is right there, page 264. 8, 10, and 14 to 24 evens. I got to get 2 homework scores from you from the last couple days.